Okay, so for number 5, it's the same thing. We're just graphing two inequalities. So for the first one, you may want to consider rearranging y. So remember, you just need to move stuff around. So if we have 3y plus 5 is less than or equal to negative 6x minus 4, we want to get isolate y, so we'll subtract 5. So we would get 3y is less than or equal to negative 6. Negative 4 minus 5 is negative 9. Negative 6x. Divided by 3. We don't flip the symbol. We're not dividing by negative. So we have y is less than or equal to negative 2x minus 3. So that is our inequality. So if you can follow, I did this one in red. The y-intercept was negative 3, right? Y-intercept's negative 3. So in red, I did a dot on the y-axis on negative 3. If the slope was negative 2, you want to put it over 1 if you don't see a denominator. So we go down 2, right 1. So I'll start at the y-intercept. Down 2, right 1, dot. Down 2, right 1, dot. Down 2, right 1, dot. So then we draw that red line. Because of this line underneath, it means it's going to be a closed line. And when we figure out shading, it says less than y. Y needs to be isolated. And if it says less than, it's going to be under that line. If you tested 0, 0, by plugging it in, you should always test. It's the most accurate way to do it. If you plug in 0, 0 into the inequality for x and y, you would get is 0 less than or equal to negative 2 times 0 minus 3. Is 0 less than or equal to negative 3? No. So we're not going to shade the 0, 0 side. That's why we shaded the other side of the red line, not the 0, 0 side of the red line. Focus on one at a time. Now in black, or sorry, it looks brown, we have negative y plus 2x greater than 4. You could isolate y, or you can find x and y intercepts. I like to find the intercepts. So if I want y, I put 0 in for x, cross off, divide by number in front of y, it's a negative 1. Multiply or divide by negative, you have to flip that symbol. So don't worry about it saying y is less than negative 4. Just focus on it saying y and the number 4. So on the y-axis, we do a dot on negative 4. And then when we solve for the x-intercept, we insert 0 for y, divide by 2, and we get x greater than 2. So on the x-axis, we do a dot on 2. So see, I'm going over the brown and green. And we look at the symbol. Because of this symbol, we know it's dotted. So notice this brown line, and going back over it in green, is dotted. And to test shading, I tested 0, 0. Now 0, 0 is on this side of the brown line, right? So when I test 0, 0, I plugged it in, and when I plugged it in simplified, 0 was not greater than 4. So I am not shading the side 0, 0 is on for the brown line. That's why we shaded the opposite side. Now number 6 and 7 are a little different. Number 6, it's going backwards, right? It says write the inequality. So I know there's a y, an mx, and a b. So first I zone in, I try to find b, the y-intercept. Now if you zone in closely, this is a 1 right here, this is 2, this is 3. But in between there's tick marks. That means then we're counting by halves. So technically right in here that's 0.5. That's why this is then 1. So then this would be 1.5 and this is 2. So you should have to be careful. So the y-intercept, where it's touching the y-axis, it says the number 1. So the b, the y-intercept, is a 1, a positive 1. Then the slope, we know it's negative because your line is falling, right? When your line's falling, your slope must be negative. And we do rise over run. So I go from one point to another. If I go from here to here, I would go down. Now be careful. Down a half, down 1, to the right a half, to the right 1. So I went down 1 and right 1. So that's why the slope was negative 1. And we put that in front of x. The y's on the other side. Then we see where the shading is. The shading was on this side. So the shading is on the greater side, the above side, and it's or equal to because the line is closed. So this is our inequality. Then for the other one, for number 7, let's zoom in. Y, mx, and b. So first, if we look for b, our y-intercept, we see it touches the y-axis at -2. So we write that first. We know the slope is 4. It's positive. So if we go from this dot to another good intersection, I'm going up 1, 2, 3, 4, and to the right 1. So I went up 4, right 1. So that's why up 4 is +4, right 1 is 1 on the bottom, which is 4. So it's y, 4x, -2. Now the symbol is greater than. Be careful. You can use a little trick we have, but I think it's always best to test. So if you notice 0, 0, let me do a different color. 0, 0 is in red. It's on this side of the line. I showed you with an arrow. So if I test the point 0, 0, you can test any point. I'm asking myself, is it on that side of the line? So I plug it into the inequality, 0 greater than 4x minus 2, or sorry, 4 times 0. Yes, that makes sense. Therefore, this symbol should make sense. And if you think about that trick we were talking about, the person is walking on the shaded side above ground. The person's on the greater side, so it's a greater symbol. Because it's dotted, there's no line under. It's just y is greater than 4x minus 2.